so let's go. So class, Joseph. Okay, yes. Okay. All right, this is actually going to be a quick one. If you have your calculator, please take that out. Okay, we're going to do the slope field again. And let me pull up mine. So I will get here in a second. There you go. All right. Says, using the slope field, represent the solution dy dx is equal to y. Okay. So for right here, from our thing, calculator, I'm in graph. Step by step, walk me through it. Menu. Yeah, diff EQ. Y1, very good. So Y1, that's the trick. Okay, you got to put what function it's coming from. Enter. Bam. Now, there's a pattern to this. It's actually clearly a pattern. So let's look. So dy dx says what? What is dy dx? What does it actually stand for? Derivative, but what does that give me? Slope at a point, right? If it's equal to the y value, right? So my slope is equal to whatever my y value is. So if I look right here at, let me change my window real quick, make this a little bit easier to see. And go tab, up, iteration B1. There. Alrighty, let's see. So what this really means, now I'm going from -2 to +2 in my x-axis, but the y values. So let's see. So if I'm starting here at 0, right there, 0 right there. Anyway, so right there, and it goes up to 2 up here. So what do you think this value is right there in the middle? Should be 1, right? Okay, so now, according to this equation, my slope is equal to the y value. So if you look at all these right here going this direction, so I don't mess this up again, all this in this direction right here, so slope is 1, right? What do you think the slope is right here along the x-axis? 0. So you see the pattern as it's coming through, right? So as I go up, what do you think the slope is up here at the top? 2. Now as I go down below the x-axis, down here, right here where my thing is. So it's going to be, my slope is -1, and the slope over here is -2. So for any function, I can give you a coordinate to get a particular solution. A particular solution. And it can go through, and I can plot it. So if I said, hey, what would the particular solution be at, let's say, -1, 1? It would be through that point right here, -1, 1. And so from right here, the slope goes up here. And as it goes, you'll see it actually slowly start going up higher and higher. So I'm going to go, and I'm going to actually, what I showed you, hit tab, go back up to my first function, and I'm going to enter it here. So -1, 1. So there we go. So what it's doing is, it is actually estimating the slope at every single point here, getting me a dotted line. So it's an estimation. So if you were actually trying to get it more accurate, your calculator gets bogged down big time. So we could get it to have a point, everything right there, or we could do the math to find the solution, to find out what the solution would be at that point. Does that make sense? So when we plug that in right there, that's an estimation of here. On the AP exam, they will give you one of these, and they're going to say, hey, just sketch what it is, where it would be. So you put it through the point here. So now, basically what you're doing is you're finding points, and you're plugging in and figuring out the slope there. And you're just following it like that. Does that make sense?
Yeah, sort of.
Yeah. So whatever the pathway this goes, so you go down this way. Okay, here's my next one. Oh, okay, what's the slope here? It's this way here. And then that gives me that point right there. Okay, what's the slope right here? It's leveling out here. Same thing right here. So this one right here is going to give me to that spot right there. That spot changes angle, and it goes up there higher, right? So every time it's going to give you the next point, and you just find it at that point, and just whatever that slope is, change it the direction. So it would be a bunch of, there you go. So every time you do it, it's going to be basically a straight line from one to the next that you have, and then as you keep going, it's going to go up like that. So it's not going to be very pretty. It's not going to be exact. If I want exact, then I would actually have to do the actual formula to do it.
Doesn't matter where you choose though, right? So say you choose like -2, 1 or something.
Yeah, then you would actually have something that follows these, that follows the slope field to go along with it. So you said -2, 1?
Yeah.
Let's do the math then. So I know that it is dy dx is equal to y.
But hold on, it doesn't really matter though, right? If it asks you to draw it, you just draw whichever one you choose basically.
If they ask you to draw it, yeah. So you're like, okay, through this point, you would start with that point. So you said right here, okay? Through that point, okay, so that means it's going to go this way. This one's going to go down faster here. So it's going to go down faster here. This goes back this way. This one levels out this way, levels out this way, like that. Make sense?
Yeah.
Okay. So picking that point right here, separate it out, I get 1 over y dy. is equal to dx integration right here, and I get ln of absolute value y is equal to x right there plus c, and then what point did I use? I used -1 and 1, right? Huh?
Yeah.
Yeah. So -1 comma 1. There you go. So y is going to be 1. What is ln 1? 0. ln 1 is 0 equals x, which is -1 plus c. So c is equal to a positive 1, right?
So the ln y x plus 1.
Yeah, I'm going to take this. I'm going to move that out of the way.
And then it would be y equals e to the x.
So yeah, I get ln absolute value y is equal to x plus 1.
They're trying to find y, right? You're trying to find the actual equation.
Yeah.
And then so y equals e to the x.
Okay, so this is e both sides. So this is going to give me y equals e to the x plus 1. And then, going back to my calculator, and I'm going to go menu, graph entry, and I'm entering? Relation. So it's going to be y equals e to the x There we go. And this is the exact line that goes through here, where the slope field is always estimations. So, does that make sense?
Yeah.
Not too bad?
It's that changes based on what you choose, right?
Yeah, depends on what we choose. And that's the reason why it is in general. So use slope field representation, draw some graphs of the family of solutions of this. So we have the graph with all the slopes there. So at some point in time, they might actually say, hey, I want you to draw this graph. Okay, very small graph. I think this one is supposed to be, let's see, that's 1. So this is -4, 4, -1, and this is 3. Yeah. So they might ask you to draw that, or try and use this information to help me out. All right. There should be one thing that's very helpful. Anyone look at the pattern and give me my favorite number?
Oh, it's u.
Yeah, I've used, right? But what is my favorite number? Zero. Why is 0 my favorite number? Easy to work with, and it also takes care of a lot of problems. So if I plug in 0 somewhere, that means that I'm going to find missing values. So do I have a 0 slope anywhere there?
Yeah, at 0.
Okay, so now I have at 0. Okay, I could use that one. So at 0. So we're basically saying when x equals 0, and y equals, let's say 1, my dy dx equals 0. Okay, so that's going to help me out. So I'm going to go through and start plugging in to see how's that going to help me. So which one of these, if I plug in my values, going to give me that? Let's do elimination first.
It should be either A or C.
Okay, why?
Because you add 1 to x, that would be 1 and minus 1.
Yeah. Okay, so I can get rid of. So that's important. So that's why I started picking with zeros. And so it says, hey, bam, get rid of that, get rid of that. So it's going to be one of those.
But it's positive. I mean, because you just look at it, like a U shape, and it's like a positive U shape. It's concave up.
Why? That right there. So it's got to go, I got to have a positive slope, don't I? So on all these, no matter where it goes, I'm going to have a positive slope. So that means my answer has to be
X. I mean, then you also work it backwards. You can try to tell the quadratics that you just anti-derive the actual thing. The x squared.
okay. So we can,
Yeah, 1 half x squared.
we could, right? We can go through and start actually plugging in and actually going through working it out to see what you get, right?
Yeah.
Anything else we can get out of it? There's more of these. So let me see. There's that problem there. Is there another one? Nope. All right. So there we go. Example 3. Next one's Euler's. Yeah. So we're gonna pick that up next week, and test is going to be, what did I say? Thursday? Yeah, Thursday next week. Because we still have a couple days to finish this.
You should really put that to Friday.
Huh?
You should really put that to Friday.
Why?
Um,
Why? Because most people just don't show up on Fridays?
Oh, you're right. I don't think anybody will show up on Thursday either.
Why?
Thursday's like the weird day out of the week. It's like Monday's start of the week, so people don't show up. Tuesday's when people actually show up. Wednesday people show up.
But Tuesday, we could test on Tuesday, but we're missing days of, like, you should have 4 days to actually work on these problems.
I'm not saying doing it on Tuesday. Tuesday's like,
Yeah.
that's way too soon.
And I try not to do it on Wednesday because,
That's a short.
yeah, so we don't have an advisory.
That kind of didn't work out last time.
Yeah, and people have other things that they'll go to, but not, to bring up their math tests. So.
And Thursday, I don't know. I mean, Thursday's like half and half. It could be either everybody shows up or everybody doesn't show up.
Today's a Friday, and look how many people showed up. Anthony! I'm glad you showed up. All right, you guys use this time wisely. Try and get some more of these done, especially since the calculator problems are, you're going to have some of these, so make sure you are using that.